Myself Prayag Patel, working as an assistant professor in IT ICT department of LG Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the heap sort algorithm. In our previous video lecture, we already discussed about the heap sort technique or example of the heap sort. Now in today's lecture, we consider the algorithm of the heap sort method, how a heap sort algorithm will work. Now consider this algorithm for heap sort technique. First, input array A means you have give one array as a input array. Now output means sorted array A. You require one array as an input, then sort this array using the heap sort algorithm and resultant array consider as an output. Now consider next name of the algorithm, heap sort A1 to N. So here heap sort consider as a name of the algorithm. Now A consider as an argument array A from 1 to N. Now first step of the algorithm is build max heap A. So consider the build max heap A as another function or function call from the heap sort algorithm to the new function as a build max heap A. So here consider the first function as a build max heap A. Now how you can perform this operation? We can consider the build max heap function for construct the heap tree. In heap sort algorithm, first you construct the heap tree, and heap tree construction will done using the build max heap function. After that, consider the next step as a for I equal to length of A down to 2, means you can start the process from the length of your heap tree and down to 2. Do exchange A of 1 with A of I, means first element exchange with the ith element. Then heap size of A equal to heap size of A minus 1 means decrement the heap size, and last one is max heapify function A1n. So here consider this algorithm. First consider one by one function. First function is a build max heap. So consider the another function or another algorithm as a build max heap A. Now first step is heap size A equal to length of A. Here consider the one example for 1 3 2 9 7. This is a given data for sort the data using heap sort algorithm. So construct the heap tree for this data is like location wise you can put the data or value for then 1 then 3 then 2 then 9 then 7, and position wise we can consider location 1 to 6. Now heap size of A equal to length of A. So here consider the length of A equal to size 6 because here total 6 number of element. So that's why we can say that length of A or heap size equal to 6. Now next line consider as a for I equal to length of A divided by 2 down to 1. Means consider the length of A as a 6. Now 6 divided by 2 means consider as a 3. So 3 is your starting value for I, and down to 1 means your I value consider as a 3 then 2 then 1. So here consider one by one value. Initially first consider the I equal to 3. So we can say that this in this heap tree you consider the root node as a node number 3, position 3. So here consider this node as a position 3, and consider the subtree of the I equal to 3, means consider the subtree as a 3 and 7 node. So consider this two node 3 and 7 and check the process or maximum heapify function. So here this is an example of the maximum heap tree. So that's why we can say that parent node is maximum than child node. So here check the condition for the maximum heapify function. So here parent node is 3 and child node is 7. So 3 is greater than 7 condition is not satisfied. That's why we can swap these two elements using the max heapify function. Here consider the function as a 2, max heapify A of I. So here consider the I as a 3. So A of 3 at the position 3 you can maximum heapify function, apply the maximum heapify function, means you can swap these two elements, means consider the 7 as a parent and 3 as a child. So you can see that here after swapping operation your tree is like this. 7 is a parent node and 3 is a child node. This is considered as a maximum heapify process or probability is checked. and maximum Heapify process is done. Now consider the decrement operation of I. So consider the next value of I as a I equal to 2. So down to 1 up to 1 you can check the value of I. Now consider the value of I equal to 2. Means you consider the node number 2 as a parent node and node number 4 and 5 consider as a child node. Now check the condition of the max Heapify, because here function is do max Heapify A of I. So here max Heapify process is done. Now consider the 1 as a parent node and 2 and 9 consider as a child node. So out of these two child node, consider the maximum node or greater node as a parent node. So here consider the 9 as a parent node and 1 as a child node. So swap the 9 and 1 and resultant tree consider as a 9 as a parent node, 2 as a left child and 1 as a right child. So this is considered as a maximum Heapify operation for A2, means consider 2 as a parent node. Now down operation or exchange the 9 and 1 already be done. Now consider the I equal to 1, because you can perform the operation for I equal to 3, then 2, then 1. So for I equal to 1, consider the root node as a node number 4. Node number 1 means value considered as a 4. Now child node of 1 is location 2 and location 3. So check the two node 9 and 7. Out of these two, consider the 9 as a greater value. So perform the max Heapify operation at node number 1 I equal to 1. So check these two node 4 and 9. 4 is less than 9 means 9 is greater than 4. That's why we swap the element 9 and 4. So here consider the after swapping of 9 and 4, your resultant tree, last tree consider as your resultant tree, and in this tree consider the maximum Heapify property is satisfied. So here 9 is a parent node, 4 as a left child, 7 as a right child, then 2 as a child of 4, 1 as a right child of 4 and 3 as a left child of 7. So this is a maximum heap tree. So build max heap function is done. So in our algorithm we already consider the build max heap function, and according to build max heap function you design a one heap tree or maximum heap tree. After that consider the next line of algorithm is for I equal to length of A down to 2. Means you can start from the length of A, means from the I equal to 6, and consider the up to the node number 2, location number 2. Now next function is do exchange A of 1 with A of I. Now here consider the I equal to 6 because length of A equal to 6. So here consider the A of 1 exchange with the A of I, means A of 6. So here consider the swapping of node number 3 and node number 9, because we already see that here 9 at his proper root node position and 3 as the last position. So swap 3 and 9 according to exchange A of 1 with A of I. After that next function is heap size A equal to heap size A minus 1. Means you can remove the one element from the heap tree, decrement the size of the heap tree. So here consider the last node, remove the last node position 6. After that next operation is considered as a max Heapify function. But here consider the we remove the last node as a 9. So consider the 9 element as already sorted element. Now consider the next function as a max Heapify A1n. Now consider the function, how max Heapify function will work. For understanding this, we consider the another function as a max Heapify function. In max Heapify function, consider A as a array A input, then 1, then size of n. Now consider the max Heapify algorithm. In this algorithm, consider the same example. Here consider the example as a 3 as a root node, then 4 and 7 node as a child node, then 2 and 1 as a another child node. So here consider the after swapping of the first node and last node, you have a this type of tree. Now consider the value of I. What is the value of I? I equal to 1, because here we consider the function as a max Heapify A1n. Now L equal to left I. So here consider the L means left child of the I. So I equal to 1. So left child of 1 consider as a node number 2. Now R means right of I. So right of I means right of node number 1, position number 1. Then consider as a position number 3. So R equal to 3. L means 2 and R means 3. Now consider the next condition as a if L less or equal to N and A of L greater than A of I, then largest equal to L. Means here we check L is less or equal to N. Yes, because N equal to already 6. Then L consider as a less than of N, and A of L greater than A of I. Here consider A of I. A of I means A of 1. A of 1 means 3, and A of L means A of 2, and A of 2 equal to 4. So 4 greater than 3 condition is satisfied. Yes. Then largest equal to L means here consider the L as a 2. So largest consider as a 2 according to this function. Now else part, else largest equal to I. If A of L greater than A of I condition is not satisfied, then largest consider as a I as it is, no any change. But here consider A of L is greater, that's why we consider largest equal to N. Now consider the another function if condition. If R less or equal to N, then A of R greater than A of largest. Means here check the condition R less or equal to N. Yes, because R equal to 3, N equal to 6. And A of R greater than A of largest. A of R means A of 3 greater than A of largest. Largest equal to 2. We already said largest equal to 2. So A of 2. A of 3 means consider as a 7 and A of 2 consider as a 4. So 7 is greater than 4 condition is satisfied. Yes. Then here consider the condition is satisfied. Yes. Then largest equal to R. So here consider the largest equal to 3. After that check the condition. If largest not equal to I, then exchange A of I with A of largest. So here consider largest means 3 and I means 1. Position 1 consider as a I and largest position consider as a 3. So I not equal to largest. That's why exchange A of I with A of largest. So here consider the exchange operation between the node number 1 and node number 3. Position number 1 and 3 means node 3 and 7 will be exchanged. So here consider the 7 consider as a root node and 3 consider as a right child. After that consider this node as a maximum Heapify operation is satisfied. After that next operation is max Heapify A largest N. Means after performing this Heapify operation, you recursively call the max Heapify function for further tree expandation or further tree check the maximum Heapify condition. So this is considered as a max Heapify algorithm. Now consider the complexity of this algorithm. So here consider first we execute this statement I equal to largest of A down to 2. Then do exchange operation from A of 1 to A of I. Then consider the heap size A equal to heap size A minus 1. Then max Heapify A 1N. So this loop for I equal to length of A down to 2 will be executed for N minus 1 time because we start from size of heap tree to 2. So consider N minus 1 operation. And here consider the another max Heapify function, and max Heapify function required the log n time. So consider the complexity like this. So build max heap function executed for n log n time. Then max Heapify function executed for log n time. Then I equal to length of A down to 2 executed for n minus 1 time. So final complexity will be, or final running time of the heap sort algorithm is, we go n log n plus we go log n into n minus 1. So final complexity is we go n log n. So heap sort complexity consider as a n log n. So this is a heap sort algorithm analysis part. So in today's video lecture I will discuss about the algorithm of the heap sort as well as analysis of heap sort, how heap sort algorithm will work and how analyze the heap sort algorithm. Thank you for watching.